Welcome back. We left off here with the rear wheel mounts. In red here, these parts will mount the spindle to the frame. In order to make these parts, it's not enough to just drill a couple of holes, it'll be necessary to machine them as well. So I'll be casting these parts out of aluminum slightly larger than they need to be, and then machining the rough castings down to the part's final size. Well, to do this, I'm going to need some new tools. First up is this Grizzly benchtop mini mill. I'd never done any manual machining and would have to learn along the way. Considering that a single custom fabricated aluminum part can cost from hundreds to thousands of dollars. In fact, it's only when you make thousands of parts that they get really cheap. Casting and then machining the parts by hand seemed a better way to go. Next is a Grizzly benchtop lathe. The mill and the lathe are the foundation of industrial manufacturing, and were actually invented in their modern form by Eli Whitney of the cotton gin fame, with the aim of making consistent, repeatable, accurate parts. So let's go ahead and make these parts. The piece is cut again from pink polystyrene foam in my hot wire foam cutter. A flue is added to the part. This will stick out above the sand when the part is buried, and is where you pour the molten aluminum. And here is the result. Raw castings, cleaned a bit with the flues cut off. These were clamped to the benchtop mini mill, and first the upper round surface was milled flat. And next it was flipped over, and the other side was milled flat. This is a bit of a laborious process, which requires constantly turning small cranks to pass the cutting piece over the metal, and then move over a small amount, cut another row, and repeat again and again and again. Next, these parts were moved to the lathe. Actually, I lacked the appropriate tool I needed for this cut on the inside of the small diameter part, so I just welded one up real quick and screwed a triangular cutting piece to the end of it. Not too bad for 15-minute tool creation. In this picture, you can clearly see the successive layers getting scraped away as the triangular cutting tool is moved forward into the part. Comparing the cast part with the machined part shows the significant difference after machining. And here's the second one, also machined. There are some casting imperfections on the surface here, but these are minor and do not penetrate deep into the metal. Next up would be the mounting brackets cut from 1/4-inch thick plate steel with the plasma cutter. I also cut and welded the headrest portion of the bike. By now I had found that small A-shaped metal rack quite insufficient for my ever-growing supply of metal, and since I was in a bigger shop I went ahead and made the metal rack taller and wider. Here I was chilling in the new house shop, sorting metal and designing that metal rack. I spent a good deal of time modifying my V-Strom, preparing it for a trip from Connecticut to Chicago, about 1,000 miles. Here's the V-Strom with a nice laptop GPS tank-mounted touchscreen and 2 GV side cases and a GV tall windscreen. Not more than an hour later, and less than 100 miles, this happened. Sadly, I T-boned a car doing about 30 miles per hour at an intersection. I hit the car hard enough that the car rotated about 90 degrees. My V-Strom stopped dead. Luckily the car was a sedan and not an SUV. I was thrown over the car and got quite a perplexing set of injuries. I was pretty badly bruised, but thanks to the extensive safety gear I had on, nothing was broken. I actually hit my head hard enough to lose consciousness, so I don't even recall the accident. But within a couple weeks, I collected my insurance check and got another V-Strom, this time the 1000cc version. It did take about 9 weeks to get almost back to normal. Anyway, back to the Akira bike project. You saw the spindle mounts completed, the blue parts in this image. So now it was time to make the hubs for the rear wheel. The hub is actually split into 2 parts for reasons you'll see later. So I first cast the smaller of the 2 pieces. And you've probably seen this video already, but this is the actual pour of that part, the smaller of the 2 hub pieces. The other part of the hub would be the largest piece I've cast yet, and required more aluminum than my crucible could actually hold. So I had to build an additional crucible and pour both simultaneously with a friend's help. Here are both crucibles fully heated and full of molten aluminum, ready to pour in the kiln. These took about 90 minutes to heat up enough. Here is the lost foam pattern for that pour, with 2 separate flues spread out and 2 separate risers to facilitate both of us pouring simultaneously. We did practice pours a few times, counting and going through the motions of pouring simultaneously. And the results: success! This came out very well. I didn't film this, though, since focusing on getting a successful pour was stressful enough, really. And back to that first part of the hub. Of course, these parts are cast oversized and then machined down to size. Even after just a little bit of cleaning, these parts start to look pretty good. And that first half of the hub is then turned on the lathe, getting all the dimensions down to their final specifications. And the first half of the hub finished. Beautiful. Now onto the other half of the hub. The flues and risers were cut off, and the part cleaned with a metal wire brush. Getting ready for the milling machine. The rotary table on the right here adds another axis to your milling machine, and you can turn another crank slowly around to mill around a circumference. So I need to make the hub slightly smaller so it will fit into my lathe. But that's not going to fit here on my rotary table, so time to improvise. Since the part was too big for my lathe and my rotary table, after much deliberation, I decided to make a mounting plate that would mount to my rotary table and basically increase its effective diameter. Here is the layout on a scrap piece of 1/2 inch thick aluminum plate. The inner grooves here would bolt to the rotary table, along with those 2 bolts in the middle, while the outer grooves would bolt the part down. This was quite tedious, since you're only cutting about 10 or 20 thousandths of an inch per pass. It felt like it took hours just to cut the outer circle of the plate. Finally, the hub is mounted to the rotary table on the new mounting plate, so it can be trimmed down enough to put on the lathe. And there we got it on the lathe. After some time running on the lathe, it's completed. So here are both sides of the rear wheel mounting hub together. I then drilled some 1/2 inch holes through them that match the bolt holes on the rim. A scrap piece of the spindle tube is between them to make sure they lined up properly. Soon after, the bearings came in, which required a recess to be machined out of both hub pieces on each side. So here is the smaller of the 2 hubs with the race machined out. Aligning a piece like this on a 4-jaw chuck, at least not a very good 4-jaw chuck, is kind of a royal pain in the butt. Here it is with both sides done now, after another hour of aligning on the 4-jaw chuck. These are large, high RPM needle roller bearings, with a 2¼ inch ID. This is an unusually large spindle, and the hub mount may look over-engineered to you. The reason for this will become more apparent later. Putting everything together in a quick test of the rear wheel hub mount looks pretty promising. And now the same test, but this time jigging up the rear of the bike to the rear axle mounts. Woohoo! A rolling rear wheel. And putting it all together, it's really starting to look like a motorcycle now. The rear frame here of the prototype still needs quite a lot of work. This hasn't been finished welded yet because the drivetrain design still needs to be finalized. This phase of the prototype will be a hardtail, which means it has no rear suspension, but suspension will be added in later phases. Well, that's all for this video. Thanks for watching. I hope you're all enjoying this series. Please like, subscribe, and share, and stay tuned for the next episode.